before me asked a question that I was going to ask. How many people here are doing IP? I guess only 2 people are here doing IP. And the rest, how many people are associated with SOC? SOC development? What are the other people doing? Software? Software, but that's also SOC development. Isn't software part of SOC? Okay, well, so my talk is about how to automate and streamline the development of SOC. So it's not just the CPU. You got a brand new ISA, everybody's so happy about it, but there's also IP, like Mohit said. So you have to connect it together to make a complete system. So how do you do custom IP? So that's where I'm going to take you. So, it's a high-stake game to create these SOC, and requires, as you see, too many engineers and machines and licenses, and too much time. And there's so many steps on the way. I hope you agree with me. There are too many things to do. So a quick solution to that is to use proven technology, right? So well, we are stand on the shoulders of giants, sci-fi and RISC-V startup to sci-fi guys. Use proven IP, like throughout the day you'll be hearing about templates. Use templates and build on top of that, things that have already worked. Use proven methodology, right? Automate as much as possible and eliminate wasteful work, things that you can automate as much as possible. All the manual and duplication of work. And you'll be surprised there's so much duplication of work. And this is my main focus is, when I started the company, is have a single source, an executable specification. An executable specification that can generate everything from that. So that, there is no duplication. So, just to, this was after lunch, so I thought I'll put some cartoons in here. You probably have seen these. Anybody seen this? Yeah? Okay. So you see, this is like how the marketing will, you get a spec, like when you get a new SOC, you get this is what you need to create, a team of engineers, right? And this is what the RTL designer implements it like this. The verification teams verifies this, right? And the firmware teams, they're like this. That's probably their more, they'll probably pick me up later on. Software team, this is what they do. And then the tech bug teams, who's responsible for documenting, they do all like old glory, this is all very good, This is going to the customer. And then the customer gets this. But really, what the customer wanted was this. So you see the difference, what they wanted and what they got? And the reason for this is, the lack of a single specification. So if let's go quickly to what we're after is the SOC, and as you know, the CPU is part of it. There are all the peripherals and the various buses and stuff, sensors, and interrupts, and there's all these. How the CPU sees the IP is through the registers and the interrupts, right? That's what is indicated by these black boxes. And so, how the CPU talks to these peripherals is through this hardware-software interface layer. So what we do at Evidences is create these kind of what you guys are doing at Sci-Fi is create these library of components like these templates that you can highly configure and customize. So all these GPIO, PWM, we have these components that you can put together with the CPU, and but they are one thing that distinguishes them is that they're highly customizable and configurable, and it's a template-based approach. We were talking about templates, but Mohit, I don't see him here now, but he was talking about templates, but this is even going even further, like how to really customize and integrate that with yours. So this is an example where one of our solutions is a plugin into Word. So you created like you've created a template for register and you're basically customizing it. And you're adding things to it. And supporting different buses, standard buses, like we recently added for tiling, supported by Sci-Fi or promoted by them. And then how do you do? So library of components is one thing that you could use. But then how do you do your custom IP? You can't just be using other people's IP, right? Otherwise, anybody could do it. You have to add your own thing. And you have to add your own, you have to create your own custom IP. So how do you create those registers? Well, you have all these different types of registers that you need to define. But behind those registers is your core IP that you are creating, right? So there could be all these different types of lock, alias, shadow, and behind that is your application logic. And so the idea is to capture all of this in a single specification form. So capturing it in a single specification and then automatically generating like the RTL model, the C++, or even a RISC-V ASM for it, System C model for virtual prototyping. You gotta before you go into actual development, you gotta verify. You have to see whether things are working. You probably create a software model for it, and so System C is one of the languages that is used. So you want to be able to automatically generate that. And then if you do verification, SV, UVM models and agents, how do you create that? So all of this is rather duplicating work, creating a single specification and automatically generating from it. And of course, don't forget the documentation. Some poor guy has to use this. That would be the firmware guy. You remember what he created without the documentation? He's just going around finding out what to do. So documentation is very important for the end customer of these IPs. So automatically generating is very important, because if you don't, then it's always out of sync. Things are never in sync if you're manually creating these things. And perhaps custom outputs also. Our solution, we have something called velocity templates that you can use further templates to create additional outputs. And so this is like the whole solution in one place. So basically, create the specification either in textual formats or plugins into Word. I'll show you a sample later on, or Excel or OpenOffice if you want, and automatically generate all these artifacts from that single source. And then one point was about standards. I'm not sure how many people here have heard of them, but IPExact, SystemRDL are industry standards in this space. You have to support those, and so you can take those and generate it yourself also. And then advanced topics like clock domain crossing, worry about clock domain crossing, parity, functional safety, for example, clock gating, all these. So the point is that creating a single specification and automatically having the tools generated solve that problem. So this is an example of a Word document with, and it could be OpenOffice as well. So creating this document and then generating from it. Here is a sample of an Excel document that's capturing the same data. And then we also created a desktop application, which will kind of, people say, oh, we don't want Microsoft, or we don't want Windows. So this is like a cross-platform desktop application. So you capture all of that. So here is an example of configuration and customization. It's not just, so configuration is what I call it. Here you got like a GPIO example. You're configuring how many GPIO pins are there. And then customization is when you're getting some standard functionality from the IP vendor, but you're adding to that functionality. So sometimes these IPs that you get from the vendor may not totally solve the problem. So you should be able to extend that. So this mechanism, you can do that. So by default, it gets you some functionality, but then you can add your custom functionality. And of course, you get to add your own RTL as well. So this is like the register layer that you add, and then you can add more stuff. But again, we haven't given up the point about single source. Create that single source and then generate everything from it. And this is not limited to the registers or the IP side, but also to software. So to the device drivers. So for example, if you see the hardware registers form the core layer on which the hardware abstraction layer is based, and then on top of it you have the application layer. So again, device drivers are always a challenge, and this is how this interacts. And you use C or assembly language to create these device drivers. So this device driver, the hardware is created by or designed by the hardware team, right? The actual, like, what are the mechanics of the functionality that the hardware team needs to create. They design it, but then it is used by the verification and the emulation team, right? They need to verify it, try it out, whether it works or not. Then the firmware team needs to write these device drivers, and the validation team has to test after they get the chip back. They need to test whether this is what was advertised or not, right? So how about this is what happens typically, is that you have the design engineer saying, oh, this is how it's supposed to work, and then the verification team says like, oh, I don't know, I thought maybe it was something like this. So this is, I'm talking about the device driver now, the software side of things, right? So it looks like many people are here in the software firmware. This is the firmware engineer kind of having it wrong. I mean, the spec is there, but then everybody is doing something different, right? I mean, they are trying to see if what is the correct way of, and we've seen horror stories about months and months wasted finding out bugs which would not have been there if they had followed different methodology. Tech bugs, they're saying, what did I say? Do we need to change the documentation? Anyway, the idea of this, you know about this, right? Line flying and that's the thing, people are trying to figure out how the SoC works. So again, single source, from that, create everything. And so for a device driver also, having a single source will help. So create like a single format. So what we've chosen was Python to create a single text-based format, and also Excel, because people want maybe more simplicity. So Python or Excel, and then all artifacts from it. For example, UVM-based sequences, or also PSS. I don't know how many people have heard of it. Portable stimulus standard, that's new for in the verification space. Verilog, SystemVerilog, and MATLAB for emulation. Again, from that single specification of the sequences at a high level. Firmware C, API, maybe even RISC-V ASM, I don't know. That's something new. We'll have to investigate more. For validation, C or even SystemVerilog. And perhaps support wide range of ISA, maybe different instruction types that you have in the ISA, we support all of those. So here's an example, like configuring GPIO registers using Python. So this is like an example of the specification that's could be in Excel, could be in Python. And then from this, we generate equivalent sequences for multiple environments, like for SVUVM from that same Python. So there are other things as well, like how exactly it goes out. You specify that in some additional configurations. But the point is that you're sharing that algorithm. That is going to go all the way from the designer through the firmware, through the software, to maybe the validation team as well. So C for firmware, again from that same source, you're creating that's and the portable stimulus. That's the simple like a stub for it. So in summary, with this single source methodology works, and we have these customers and more, and some of our customers are part of your design share as well. So we help them as well, and we feel that it actually reduces the time to market by 40 to 60%. If you follow this methodology. And of course, we also at Technisys we have these fully customizable IPs for this file, supporting the tiling class as well. So I will call out to you guys, go to our site and check it out, and if not, at least try to follow that process of having a single source. Don't waste time. Thank you. Any questions? Yes.
Actually, I am working for automotive development right now. So, can we use similar technology what I is doing is for AutoSAR or that type of standards while developing complex type of devices?
Absolutely.
Is there any use case already?
Yes, so we have some automotive customers using this methodology, and absolutely, the 26262 standard in automotive really likes this process of having a single source and everything deriving from it, because they want to see traceability. So there are some additional things that I didn't talk about. They want to see traceability as well, and that is easily achieved when you have a single source and you're deriving everything from it. So absolutely. Any other questions? Thank you very much. Okay.